Welcome to another day on the Journey Chez Chem. Today we are doing a lab. I'm so excited. I can't wait. So please do the warm-up as quickly as possible and we'll move on into the lab. Now I see that we have 4 questions here, and normally we only have 2, but on the assessment you will have 8 of these types of equations to do, and they are worth 4 points for the complete balanced equation and 2 points to identify what type of reaction they are. So I thought it would be good for us to practice some of these. Now when we decompose phosphoric acid, first of all I have to know, what is phosphoric acid? Well, it's H3PO4. Phosphoric acid in its name is an exception to the rule. It has 4 oxygens, but it's called phosphoric acid and not perphosphoric acid. Now, whenever we decompose an oxyacid, I must find the charge of the nonmetal. And therefore, I'm looking for the charge of the phosphorus. Well, phosphate has an overall -3 charge. So I set my equation equal to -3. Oxygen is -2 times 4 is -8. And therefore, in this case, phosphorus is +5. Now, when I decompose an oxyacid, I always get water. And when I drive off the water from an acid, I'm left with an acid anhydride, which means an acid without the water. Now, this acid anhydride is phosphorus and oxygen. Remember, acid anhydrides are binary compounds. One of the elements is oxygen and the other is a nonmetal. We know from the beginning that phosphorus had a +5 charge and oxygen is -2. Therefore, the common multiple between 5 and 2 is 10 and compounds must be 0. Therefore, I need 2 phosphorus and 5 oxygen. First, I must get the correct formulas. Then I see that I have 2 phosphorus, so I will put a coefficient in front of the compound. I can't put a little 2 in here, that would change the whole formula. I have to put a coefficient. And I believe that then I have 6 hydrogens, therefore I need 3 waters, and then it's balanced. In number 2, we have chlorine gas, and if I were taking an assessment, I would write those diatomic molecules on the top of my paper. Chlorine is a diatomic molecule. It's reacting with silver iodide. Silver is always +1, and iodine is -1. And that's how I write the formula. Compounds must be 0. Now, this is a single displacement, and a nonmetal will take the position of a nonmetal. Therefore, I'm going to get iodine, which is also diatomic, and silver chloride. Now, I have 2 chlorines here and only 1 here. So I must put a coefficient because I must have the same number of atoms on both sides of the equation. And that's how you do that one. In number 3, I'm decomposing sodium hydroxide. Sodium hydroxide is a metal hydroxide. And whenever I decompose a metal hydroxide, or a base as this is, just like this was an acid, I always get water and a base anhydride. And sodium is +1 and oxygen is -2. Therefore, it requires 2 sodiums to get my compound to 0. Once I have this formula written, I can't go in and change the subscripts. I can only add a coefficient to balance the number of atoms. Now remember, when you have an oxyacid, you always get water and an acid anhydride. When you have a base, you get water and the base anhydride. And that makes sense. Finally, we have calcium sulfate. Calcium is +2 and sulfate is -2. And that brings my compound to 0. Now I'm going to write water as HOH because it shows me that water breaks up to hydrogen ions and hydroxide ions. And now they're going to do the do-si-do. And I'm going to get calcium hydroxide and sulfuric acid. And I also remember that this is a salt and a salt plus water gives me an acid and a base. Now here I have 2 hydrogens and here I have 2 hydrogens. That gives me a total of 4 hydrogens on that side of the products. Therefore, I must have 2 waters to get my 4 hydrogens. And therefore, it is balanced. That's not so bad. So you need to make sure that you remember how to do your decompositions and what those products are. So now I'll see you in a moment. Can't wait to see you in the lab. Get to go. Now here I have 2 hydrogens and here. Now, I just get so excited doing lab. I'm sure you're excited too. Now, the first reaction that we're going to do, I have a spot plate here, and I'm going to use equal amounts. This is a qualitative lab, meaning I'm going to make some observations. Now, I'm going to make my observations for what I see, and I'm not going to worry about it too much because I know that my teacher has set aside some test tubes that have the reactions in them, and I will be able to see that. Now, on this, you will add equal amounts. The first one is copper 2 sulfate, and I have copper 2 sulfate here, and I will just add a squirt of copper 2 sulfate. And I'm going to add potassium chromate. And I am interested in what's going to happen after the reaction, not before the reaction. I will add my dichromate, and I see that my solution is getting a little bit cloudy and kind of green. There is a precipitate in there. Now I know that these are small, and sometimes we have to look on the bottom to see the reaction, but I'm not too worried. I see that I have a yellowish precipitate and a greenish solution, but I will verify these with my test tubes afterwards. My second reaction is copper 2 sulfate. I will add my copper 2 sulfate, and then I'm going to add some ammonia hydroxide. Ammonium hydroxide has kind of a smell of ammonia, and I'll add that. And I see that I'm getting a light blue precipitate, it seems. It's kind of cloudy in there, and it's difficult to see in these spot plates exactly. That's why I want to look at the test tubes when I've completed this exercise. The next reaction is nickel 2 nitrate. Now, I know that the nickel 2 nitrate is very light in color, and this one may be very difficult to see. But I'm going to add my nickel 2 nitrate, and to it I am going to put sodium bicarbonate. Clear liquid to begin with. I add my sodium bicarbonate, and I see that I do get a precipitate. I don't know if this is very evident for you yet, but when you see the test tubes, you'll see how they work. Now I have lead 2 nitrate. I'm going to take my lead 2 nitrate and put it in the spot plate, and just a squirt. It's qualitative, remember, so I'm going for my observation. And I'm going to put some sodium iodide in here. I'm going to watch this one very carefully. Maybe we can look very carefully here. And I put 1 drop. Did you see that? 1 drop, and I got that yellow. I'll put another drop. Wow, that's a beautiful yellow. Now, the final one is copper 2 nitrate. I'll take my copper 2 nitrate and put some in my spot plate. And to that, I am going to add sodium bicarbonate. Sodium bicarbonate. And I see right away that I get a solid precipitate. And those are the 5 reactions that I'm doing. Now, I could let these settle and I could tell more exactly. However, I do have here a set of test tubes that have been sitting, and this set of test tubes will actually give me the reactions that I was looking for. So you can see that the solid here of the first one is brownish or rust color, and the liquid is actually yellow. And the second one, I have a bluish, aqua bluish solid and a clear liquid. In the third one, I have a greenish, light greenish, kind of a foamy sea green solid and a clear liquid. In the fourth one, I have a clear liquid and a yellow solid. In the last one, I have a clear liquid and a light blue, aqua blue solid. Now, it is important when you write up the lab that you identify what the liquid is. And the liquid is going to be the spectator ions. And the solid is going to be the precipitate in the net ionic equation. It's very important in the data table that you put not only the colors, but you identify the substance. And that's how we did the lab today. And that was some fun. And I can't wait to see you tomorrow.